Now we're going to solve an algorithmic problem, binary search. In this video, we'll talk about linear search as well. Also, we'll talk about time complexity of binary search and how binary search works in logarithmic time complexity. For example, if you're given this array and a target 34, we have to find out the index of the target element. If the target element does not exist in the array, we should return -1. If this target exists in the array, we should return the index of that element. You might assume that the given array always is sorted. We can solve this problem using linear search pretty easily by checking the array element one by one. Let's see how linear search actually works. First, we'll check the first element 1. Does 1 equals to 34? No. So let's go to the next element. Does 3 equals to 34? No. Let's go to the next element. Does 5 is equals to 34? No. Let's go to the next element. Does 8 is equals to 34? No. Let's go to the next element. 12 is not equals to 34. Let's go to the next element. Now we see that the current element is equals to target. So in this case, we'll return the index 5. And this is called linear search algorithm. Linear search will take big of n time complexity because for worst case, we have to traverse each element once. So the time complexity is big of n. Linear search is not an efficient algorithm to search an element in an array. Now let's talk about binary search and how binary search works. Okay, now we're going to talk about binary search. Our target is 34. Now we have to search this target in this array in logarithmic time complexity. Don't worry about logarithmic time complexity. We'll talk about in details. First, what we're going to do, we're going to find the middle element in this array. The middle element is 8. Now our goal is to check, does 8 equals to target? No. Now we're going to check, does 8 less than target? Yes, it is. If the middle is less than target, then we will discard all the element on the left, including the middle element. Alright, so we discarded the left portion. Now let's find out middle in this array. The middle is 34. And we see that we found that target in this array. In this case, we have to return the indices of this element 34. Alright, and this is how actually binary search works. Don't worry, we will see how we can find the middle element. We are given this array and target equals to 34. If we divide this array by its middle element, then this will be like this. Then if we divide this sub array using this middle element 3, then we get like this. Okay, then if we divide this sub array by this middle element, then we get like this. Okay, now we see that this is a binary search tree. Now how this actually works? Now let me ask you a question. How do you search a target value in a binary search tree? First, you check the value of node and the target value. If the target value is greater than the value of node, then we will go to the right subtree. If we see the target is less than the value of node, then we'll move to the left subtree. And we keep doing that process until we found our target value. Okay, now let's search 12 to this binary search tree. First, we're gonna check 8 and 12. Does 12 is greater than 8? Yes, it is. So let's go to the right subtree. Now let's check this target and this value 34. We see target is less than 34. So we'll go to the left subtree. And we found this element. Do you see here? We found 12 by 3 steps. Okay? 1 step, 2 step, 3 step. We don't have to visit all elements. We're just visiting 3 elements. Okay? Now let's see how we can find a target value 5 in the binary search tree. We have here target equals to 5. First, we're going to check 8 and 5. Does target is greater than 8? No. So let's go to the left subtree. does 5 is greater than 3? Yes, it is. So let's go to the right subtree. And we found this value 5. And this is how we can search a target value in a binary search tree. Binary search algorithm works exactly like this. Now let's see how we can find the index of our target element in an array. We're going to find out the index for target 34. Okay, first we're going to declare two pointer left and right. Left point to the first element and right point to the last element. Then we're going to find the middle, and this is our middle. How we can find middle? We can find middle by doing a simple formula: left plus right divided 2. 0 plus 6 divided 2, 3. So this is our middle. Now we're going to check, does the target is greater than this middle? Yes, it is. So we'll move the left pointer to middle plus 1. So left pointer will point to this element 12. Now our goal is to find the middle for this array. Okay, so 4 plus 6 divided 2, 5. So 34 is our middle. Now we're going to check, does target equals to 34? Yes, it is. So we'll return the index of this target. So we'll return the index of this element, that is 5. And this is how we can search an element in an array using binary search. And how many steps we have done? So we found 34 by 2 steps. Just by 2 steps. We don't have to traverse the entire array to find a value. We found 34 by doing 2 steps, this middle and this middle. And this is how we can search an element in an array using binary search. Now let me show you how this actually works using pseudocode. First, we're going to declare a function search that takes an array and a target as input. The array always is sorted array. Binary search doesn't work for unsorted array. The array must be sorted. Then we're going to declare two pointer left and right. Left point to the first element, right point to the last element. Then we're going to run a while loop until left is less than or equals to right. Then we're going to calculate mid, left plus right divided 2. Then we're going to check if the middle element is our target, then we will return index of the middle element. If not, we will check if the target is greater than the middle element, then we'll move left pointer to the next of middle. If not, then we will move the right pointer to the left of middle. At the end, if we haven't found this element target in the array, we'll return -1. Now let's see how this works. We're given this array and a target value 34. We have to find the index of this value 34 in this array. First, we're going to declare two pointer left and right. Then we're going to find the middle, and 8 is the middle. Then we're going to check, does the middle element equals to our target element? No, 8 is not equals to 34. Then we're going to check if target is greater than the middle element, then we'll move left to the next up middle. And we see that 34 is greater than 8. So we'll move left to the next of middle. Then we're going to calculate middle for this subarray. Okay. And the middle in this case 34. Now we see that 34 is equals to target. So we will return middle. So we will return the index 5. If we see a target value doesn't exist in this array, we'll just return -1. If the target does not exist in the given array, then this if condition will never be evaluated true. For this input, it will return 5. 5 is the index of the value 34. That is our target as well. Now let's see the time complexity for this problem. For first iteration, the length of the array is n, where n is the length of the given array. And we can rewrite this like this, n divided 2 to the power 0. For second iteration, the length of the array will be n divided 2. Because each time we're dividing the array by 2 halves. For third iteration, n divided 4. Then for fourth iteration, n divided 8. We're dividing the given array by 2 halves each time. For kth iteration, the length will be n divided 2 to the power k. After k division, the length of the array will be 1. In that case, the left pointer, right pointer and middle pointer will point to the same element. Then length of array for kth iteration will be 1. Then if we do this math, then we will get this time complexity big O of log 2n. Alright guys, so the solution will take big O of log 2n time complexity and constant space complexity. Hope this concept was clear. If you have any question, if you have any suggestion, let us know. If you want more video like this, subscribe to the channel. Thanks for watching this video. I will see you in the next video. Till then, take care.